All right, we're going to start section 3.4, supplements and complements today. Start by introducing the terms that we need for this section. Going to do some word problems, introduce a couple of theorems, and do some proofs. So let's go ahead and start by defining what complementary angles are and supplementary angles are. So complementary angles are when you have two angles that add up to 90 degrees. Or form a right angle. One cheating way to remember this, that 90 degrees is complementary, is just by sticking a little line right there, and you can see a 90 at the beginning of the word complementary. Supplementary angles are when you have two angles that add to 180 degrees, or form a straight angle. And this is, I know this is a huge stretch, but you can stick a 1 in front of here, go like, stick a thing here and a thing here, and it sort of looks like a 180 at the beginning of the word supplementary. Okay, so if I have an angle, let's call it x, then the complement to that would be the other angle that makes up the 90 degrees. So the complement is going to be 90 minus x. And the supplement to the original angle x would just be this entire angle here that makes up the entire straight angle, and that's going to be 180 degrees minus x. So that's going to be the supplement to angle x. The reason I bring this up is when you're doing some of these word problems, like the one down below, start with problem number 1 here. You want to try, the best way to approach these is to translate the sentences very directly. So when it says here that the measure of one of two complementary angles, it's talking about either x or 90 minus x. Let's go ahead and use x is, translates to an equal sign, 3 greater than twice the measure of the other angle. So the other angle, twice the measure of the other, is going to be the 90 minus x. So 2 times 90 minus x, and 3 greater than would just be plus 3. And from here I can go ahead and solve for x. I'm going to trust that you can do the algebra on this. So x ends up being equal to 29. And then you have to check to see what is the question actually asking for. In this case, it's asking for both measures. It's asking for the angle, 29, as well as the complement, so it's going to be 61 degrees. Okay, let's try the next one. So the measure of the supplement of the angle, which is going to be 180 minus x, is 5 times the complement. The complement we know is 90 minus x. Solve this thing for x. We end up with x is equal to, I believe, 67.5. You should probably do the algebra on that. But we have to look at what the problem's asking for here, the measure of the complement. And in this case, the complement is going to be equal to 90 minus x. So that's going to be 22.5. All right, so now we're moving on to the back side of the first page. So we're moving on to page 2. And we're just continuing to do some of these word problems. Find the measure of well, you start with the measure of the supplement of the angle. Again, 180 minus x is, again, translates to an equal sign. 30 degrees less than, so whatever the next thing is going to be, 5 times the measure of the complement, it's going to be 30 less than that, so minus 30 at the end of that. So 5 times the measure of the complement, and then 30 less than it. If I said 30 less than 90, I would get 60. Just take 90 and subtract 30. So that in this case, I'm going to subtract 30. Simplify this, you're going to get x is equal to 60, and it's asking for the 2/5 of the measure of the complement. So in this case, I'm going to find the complement, which is 30, and then multiply it by 2/5, and I'm going to end up with 12 as my answer. Okay, hopefully that's enough of the word problems there. Let's jump to part 2 here, and let's talk about the theorems that we're going to use on the proofs. So for this one, it's given that this is a right angle, and it's given that this is a right angle. You know that this angle in the middle here is 60 degrees. And because this angle in the middle here, this angle right here, sandwiched between the other two angles, is the angle that's overlapped between the two right angles, you know that both of these are going to be 30. They're going to be congruent to each other. So the theorem works like this. If angles are complementary to the same angle, this middle angle up here, this middle yellow angle, to the same angle, then those angles are going to be congruent. And similarly, if it says that f is complementary to g, so these are comp to each other, they add up to 90, let's say this is 60, so this would be 30, and I know that g and j are the same, they're congruent, this must be 60, and I know that these two are complementary also, so this is going to be 30, so that means that these two are going to be congruent to each other. So the theorem works like this. If angles are complementary to congruent angles, then they're congruent to each other. Okay? And there is an abbreviation for these theorems that I'm going to allow you to write. Now, one thing I want to point out here is that for both of these, the word supplementary works also, in addition to complementary. So if angles are supplementary to the same angle, then their angles are congruent, and if angles are supplementary to congruent angles, then they are congruent. All right, let's try some proofs. Proof number 1 on the 3rd page here. You're given that NOP is congruent to SRP. You're given that these are complementary. So that means you have a right angle here and a right angle here. And you want to prove that this angle is congruent to this one. And so this is all the information you actually need. You know that these are congruent to each other. So therefore, if they're both complementary, these have to be congruent to each other, which is what we're looking for here. So this is going to end up being a 2-step proof. Step 1, you're given. Step 2, you know that angle POR is congruent to angle PRO. PRO. And the reason is going to be complements of congruent angles are congruent. Okay, let's try another one, since that was just a 2-step proof. Okay, next one here. given that this is a right angle here, and this is a right angle, it's sort of like the problem on the front side with the overlapping right angles. And you want to prove that 1 is congruent to 3. So we know that in this case you're looking at two angles that are complementary to the same angle, and therefore they're congruent to each other. But it's more about the setup. So let's figure out how we need to set things up to use the theorem. So you have the given, and in step 2 you can say that angle AOC and angle DOB are right angles, because if perpendicular then you have right angles. Step 3, you need to establish the complementary. So angle 1 is complementary to angle 2, and angle 3 is complementary to angle 2 also. And here's where you have to use the definition from the first page of the word complementary. So keep in mind that definitions are reversible. So in this case, rather than saying if complementary, then you have two angles that form a right angle. You're going to say in this case, if two angles form a right angle, then they're complementary to each other. And then in step 4, hopefully you can see here that 1 and 3 are complementary to the same angle. So I know that 1 is congruent to angle 3. So I can say that comps of the same angle are congruent to each other. Alright, let's try one more problem down at the bottom here. Then I'll let you give it a try. Alright, given a diagram, you know that 6 is congruent to 7. And I want to prove that 5 is congruent to 8. That's what we're trying to prove here. Okay, and hopefully you can see that in this case, these two angles are supplementary and these two angles are supplementary to each other. And so, it's more a matter of how we set this up. Now, what I probably need to do is I need to say that angle ROS and angle OSE are straight angles. Assume from the diagram. And then from there you can say that angle 5 is supplementary to angle 6, and angle 7 is supplementary to angle 8. If straight angles, then supplementary. Okay, however, from here on out, you don't need this first step. I can jump straight to this step right here. I can jump straight to saying they're supplementary to each other. And now I can say that angle 6 is congruent to angle 7. So these two are congruent, and therefore these two are congruent to each other. Okay, so angle 6 is congruent to 7. That's given. Oops. And then in the last step, I can say that angle 5 is congruent to angle 8, and the reason would be Supps of congruent angles are congruent. Okay, hopefully you understood what we're doing here, and go ahead and give things a try. Okay, take care.